In this tutorial, we are going to understand logistic regression in detail. So we have covered linear regression so far in this machine learning playlist, and we have discussed supervised learning is of two types, which is regression and classification. So linear regression belongs to the regression model. So in regression model, we try to obtain a real valued output, which is a line or a curve that can help us do the prediction. In classification, we have discrete outcomes. So the logistic regression is going to be our model, which belongs to the classification model. So although the name logistic regression has regression in it, it may confuse us that it is a regression model, but it's not. So it's basically logistic regression because we are going to use regression to do the classification. You'll be able to understand that in a few minutes. So now what we are going to see is in a classification model, what we do is we try to classify a particular data point as it belongs to some class. For example, let's take a email or a spam classification machine learning model where we have a data set. Because it is a supervised learning, we have a data set, and in that data set we have some example of emails which belongs to a spam or not a spam. So if there is an email, it belongs to a spam, we are going to say that it is a spam, and then we have some emails that belongs to not a spam. Then what we try to find is in our classification model, we say that now you are given a particular email and then you will have to classify it as a spam or not a spam. So let's see how logistic regression can help us do that. So let's get started. So now consider this graph here, this graph 1. Take a look at this graph. Now I have plotted some points on this graph using the housing price dataset. Now in the dataset, we have the area, and according to area we have prices also. So we have these data points. So this means that we are going to do supervised learning. Now in the data set, it is also mentioned whether the house with particular area and a particular price is a luxurious house or not. Is a luxurious house or not. Now you can see here the red points here, the red points represent that the house is not luxurious, and the blue crosses here represents that the house is luxurious. So you can observe from this graph that if I take the area somewhere around here, so after this area gets or we take an house with area which is greater than this point, so you will observe that most of the houses are actually luxurious. Alright, so now I'm going to ask you a question that can you draw a line that can separate all these red points from all these blue points? So the answer is yes. Essentially we can draw a line. So let me just show you how we can draw a line. So a line something like this can be drawn, and now you can observe that we have successfully separated both of these classes, which is the luxurious houses and the non-luxurious houses. Now this line is helping us do the classification of these two classes, which is luxurious or not. So let's suppose I have a green point somewhere around here. Let's take a green point here. So now you can see that if I want to classify this green point as luxurious or not, I can make use of this line, and using this line I can tell that if the point is on this side of the line, it means that it is not luxurious. And similarly I can do it in this class also. So this means that using this line, I can do the classification. So we can draw an important point here, which is we can use regression, because in regression also we try to draw a line or a curve. So we will essentially use regression to perform classification. So if somehow I will find out this line, then my work of classification or the work of the classification model has been accomplished. Now let's take a look at this second graph, and let's suppose this graph corresponds to some data set having two classes. The red point represents one class and the blue crosses represent another class. So in this case, can you draw a line which can separate all the blue points from the red points? So you can see here in this graph, it's not possible for us to create a line or draw a line which can separate both of these. But is there any other figure which can help us do that? Can I draw some other curve or some other figure which can separate out all these blue points from these red points? So the answer is yes. What I can do is I can draw a circle. Just assume that this is a circle. I can draw a circle, and this circle can separate the red points from the blue points. So again, we can use this circle to separate out one class from the other. So let's suppose I again have a point somewhere around here. Let's suppose this is the green point, and I want to predict whether this point belongs to this red class or the blue class. So since I have the circle, I can say that this circle does not lies inside of the class, it lies outside the class, so it belongs to the blue class. So that's how we can use regression. Regression is about plotting a line, in this case, or a curve or any other figure which can help us perform classification. In this tutorial, we are going to discuss logistic regression, and we are going to take a simple example of linear regression to perform the classification. And what we can do is, if we will be able to find out this line and the cost function and gradient descent of the classification model, we can just change the hypothesis function to this figure. So in linear regression, now focus on this graph. Now in linear regression, we know that we have a hypothesis function which is hx is equals to theta transpose x. Now this comes from multivariate linear regression. So we are assuming that we have multiple variables. So this is the hypothesis function of this line. Now my task to do the classification is to get this line here. So I need the theta parameters, which is theta transpose belongs to all the theta parameters in the hypothesis function. So if somehow I will be able to find theta parameters such that it will give me equation of this line, then I can perform classification. So we are essentially going to find out the theta parameters here also. But now my question is, can we use the cost function of linear regression to find out the theta parameters? So in the linear regression model, we have a cost function and a gradient descent which will find the minimum cost of the theta parameters, and then we will use it to find out the best line. Cost function is used to find out the line that best fits our data points, which means that the line that this cost function will produce is going to pass through as much data points as it can, right? And it is doing that because of the underlying concept of cost function, which is minimum squared error or minimum squared distance. But you can see that this desired line is not passing through any of the data points. So this line is not a best fit according to the cost function, but according to the classification problem, this is the desired line that we want. Same is the case with this graph also. You can see that in this curve is not passing through any point. This line is not passing through any data points. So if I will try to use the cost function of linear regression to find out this line, I will not get this line. Instead, I will get a line which will try to pass most of these data points, and it will be something like this. And this is not a desired line because this line cannot help me do the classification work. So this line, the cost function of the linear regression, is not going to work. So what should we do? Now we have to do something. We have to transform this linear regression graph, this whole graph, into a graph such that we will be able to do two important things. So I'm going to mark here these two important things. First is to separate two classes. Now you can see this line can separate these two classes. Now second point is to also best fit our data points or our data set. Now you can see this line is not a best fit of our data set because it is not passing through them. So we will have to transform this graph into such a graph that we will be able to separate these two classes, and as well as this line or any curve will also pass through most of these points, because then only we will be able to create a cost function that will try to best fit our data set. So this is a major problem that we have. We have to find out the cost function, and for that the line should pass through most of the data points, or we will have to find the best fit. So now to solve this problem, we take this whole graph and this whole line, this hypothesis function and all these data points, and we transform this whole graph into a logistic regression graph, So now we will obtain a graph which will also separate two classes and also best fit our data set. So let's see how we can transform it, and let's see what the graph will be if we try to perform logistic regression. So now consider this graph here. Now this graph is another representation of this graph. So the difference is that instead of having y as price, we have y as a discrete outcome, because it's a classification model. We are going to use a discrete outcome. So if the value of y is 0, I will say that the house is not luxurious, and if the value of y is equals to 1, I will say it's luxurious. So what I've done here is you can see all these points are now plotted in this graph, and how I've done the plotting is when y equals to 1, we have all the blue points. So you can see all the blue points are here, and similarly you can see we have all the red points here. So what we try to do is we try to find the x coordinate of each of these points. We can find the x coordinate, and then we can place them on the x-axis. So now you can see we have all the data points. So now let's say that I want to draw a line. Now I will draw a line which will try to best fit these data points, right? So let's assume that we have a line something like this. So now in this line, you can see this line is trying to pass through some one or two points in our data set, you can see this line is not even passing through any of the points, but this is actually trying to pass through the data points through our classes. So this means this line can be is also a fit, it is fitting our data set, and it is also separating the two classes. So let's see how this line is separating these two classes. So let's suppose we have a point and we take the point as a green point here. So similarly, this green point is plotted here. So what we will do is, this point is representing a house with some area. So x-axis is representing some area. So what we try to do is, we try to project it on this line, and corresponding to this we will try to find our value of y, which is, let's assume the value comes out to be 0.3. So what we say is, when the value of y is lesser than 0.5, then we assume that it is not a luxurious house, and if it is greater than 0.5, we assume that y equals to 1. Now, since we know that probability can range from the value 0 to 1, we can also say that there is 0.3 probability that this house, this house is not luxurious. Or in other words, we can also use the scale to say that there is 30% chance of this house being not luxurious. Right, so in this way we try to find out this line. Now you can see there is a problem with this line, that it tries to pass, you can see it can pass through only 2 points at most. So we need a curve or a line or any other figure in such a manner that it will try to fit most of these data points. So this line is not, you can see, is not trying to fit these points. Most of the points are not fitted. So we cannot use linear regression. You can see this is a line, so this is linear regression. So we cannot use linear regression. One major disadvantage of using linear regression is also that, let's suppose I have an outlier. An outlier is nothing but a data point which belongs to some class, but it resides outside this cluster. So you can see that this class is actually in a group, and this point is actually far away from this group. So if you will try to plot this point here, now you can see it will be here somewhere on this line, and you can see that this line will not be able to fit this data point. So we have to come up with some other curve, and that curve is of the logistic function. So instead of using this line as the output, we're not going to use this line as the output. We are going to use the curve which is given by the logistic function to to fit these data points, and then we will use the same method to find the y, and then we will find out the probability or percentage chance to predict whether it belongs to class 0 or class 1. Alright, so what is a logistic function? We will have to discuss that first. Now, logistic function is a mathematical function. It is also known as a sigmoid function and is defined as f of x is equals to 1 divided by 1 plus e raised to the power minus x. So what is special about this function? So let's try to plot this function graphically and see what is the graph that we will get. So this is a website which will plot the function given to it on the graph. So let's say our graph is 1 divided by 1 plus e and raised to the power minus x. So I will use the keyboard here. We have a raised to the power b, and here I will write minus x. So you can see that it has drawn a curve here which goes something like this. So let me just focus this graph here. So you can see that this graph goes from has a range of 0 to 1, but it never reaches 1. It reaches infinitive on 1 and 0 also. And you can see the midpoint is actually 0.5. You can see the midpoint is 0.5. And you can see this curve is going something like this. So actually we can use it to best fit our data points, right? So let's get back to our example. So we know that this graph will give me will be something like this. So it will be go from 1 and it's 0 here. It will never be equal to 1 or 0. It will go something like this. It passes through this midpoint 0.5, and similarly it goes here. So now we're going to use this logistic function to best fit our data set. So instead of using this line, we are going to use this function to best fit our data set. So let's see how our graph will look like now. So I'm going to use another color to represent this curve. So you can see now, instead of having this line, we will get a curve which goes like this, and then it will go down. This is the midpoint 0.5 here, and this is how the curve is going to go like this, right? So I will make it a little bit bold here so that you can clearly see how this curve is going. So now you can see that this linear line was not best fitting our data set, but this function can do that for us. And you can see that it will also fit the outlier. It will go till infinitive, so it will also cover this outlier. Now if I want to find the predicted value, I can project it on this curve and find the corresponding y value, and again I'm going to classify it as luxurious or not. So now what we're going to do is, instead of this line, we are going to transform this linear regression line into this curve. For that, I'm going to pass the hypothesis function of the line to the logistic function as an input. So instead of x, we will have theta transpose of x and 1 plus e raised to the power minus, instead of x, I will write theta transpose x. So now this function is going to be our final hypothesis function, which represents logistic regression, So our task is to find the right theta parameters using the cost function, and gradient descent will be able to minimize this parameter so that this curve here will be able to best fit our data set. So let's see what is the impact of this coefficient on this curve to observe how fitting can be done. So here in the graph, what I'm going to do is I'm going to multiply the x with some coefficient. So let's try with 7. So you can see whenever I type 7, the curve is actually shrinking to this side. So you can see this in action, that if I try to write -7, it gets shrinked. Again, you can see that it is shrinking. So this shrinking is happening because we are going to multiply it with the theta parameters, and since it will shrink to this side, so if there are data points on this side, it will also cover those data points. That means it will fit those data points. So if I take some larger values, you can see it will shrink some more and more, and it will go on like this. So this is how we try to find out. This is the reason why we are using the theta parameters. It will shrink this graph somewhere here, and in this manner we will be able to best fit our data set. Now we will have to calculate this hypothesis function, and after we will be able to use cost function and gradient descent to calculate these theta parameters. We will get our curve which will best fit all the points, and minimizing the cost. So if you will put these theta parameters in this equation, it will also give you this line, and this line will be able to best separate our data set. So this is the basic idea behind logistic regression. We are going to use the logistic function and a combination of linear regression, sort of combination of linear regression, to get a curve which will solve this problem, which is to satisfy these two conditions. Now you can see that this curve is also separating these two classes because we are using y as discrete value as 0 and 1, and it is also best fitting our data set. So in the next tutorial, we are going to study about cost function in detail. So that's all for this tutorial. Thanks for watching.